iiwan. Magsayang mag-aral tayo ng Math-tuto upang ika'y umasenso. Maging matyaga, maging matalino, halina mag-aral na tayo. Maging matyaga, maging matalino, halina mag-aral na tayo. Halina mag-aral na tayo. Halina mag-aral na tayo. Halina, 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 mag-aral na tayo.
Magandang araw po sa ating lahat. Maraming salamat mga Batang MANDunong and home learning partners sa patuloy na pagtutok dito sa Project SOAR, series of online academic reviews of mathematics CLAID learning modules. I'm Ma'am Karen Sota, a teacher from Andres Bonifacio Integrated School and your moderator for Week 8. Bago tayo magpatuloy, nais ko po kayong anyayahan na bisitahin, i-like at i-follow ang aming official Facebook page, Math Team, Mathematics Teachers Association of Mandaluyong. Pwede nyo rin i-like at i-share tong video na to at mag-subscribe na rin sa aming official YouTube channel, MTM Channel. Kanina ay napanood natin ang mahusay na pagbabahagi ni Ma'am Edwin ng advanced lesson for our grade 7 learners. Ngayon naman, halina't kilalanin natin ang lecturer ng advanced lesson for grade 8 learners, proving isosceles and right triangle congruence. She is an alumna of Rizal Technological University, a former Muppet teacher, and has coaching stints in district, division, and NCR meets, pati na rin sa palarong pambansa in Sepak Takraw from 2012 to 2018. A very dedicated mathematics teacher since 2014, mga Batang MANDunong and home learning partners, halina't matuto kay Mrs. JOANA Grace B. Lara.
A pleasant day, teachers, parents, and students. Welcome to our Project SOAR, a series of online academic review of mathematics CLAID modules. I am Mrs. Joanna Grace B. Lara from Andres Bonifacio Integrated School, and I will be your teacher reviewer in this quarter 3, week 8 of grade 8 mathematics. So, ihanda mo na ang iyong activity sheets, ballpen, at papel. At tayo nang magsimula. Let's go! Grade 8 students, let's learn proving isosceles and right triangle congruence this week 8 of quarter 3. Our objectives in this lesson are 1. Illustrate isosceles triangle theorems. 2. Illustrate HYL, HYA, LL, and LA congruence theorems. 3. Prove theorems on isosceles triangle. And lastly, 4. Prove two triangles are congruent. Before we proceed to our lesson, let's have first a review. Direction. State what additional information is required in order to know that the triangles are congruent for the reason given. Number 1. What will be the additional information that will be added so that triangle DUT and triangle SUT are being proved congruent by ASA? What is your answer? Correct. It is angle SUT is congruent to angle DUT. Number 2. Let's add a pair of congruent parts in triangle BAC and triangle KJL so that these two triangles are congruent by SAS. May I know your answer? Good job, guys. That is, side CA is congruent to side LJ. Number 3. Can you name the congruent parts to be added so that the triangle WVX and triangle KXV is congruent under SAS congruence question? What is your answer, guys? Correct. It is side WB is congruent to side KX. Number 4. What will be the other information so that these two triangles are congruent under SSS? May I know your answer? You got it right. This is side RS is congruent to side PQ. Lastly, number 5. What will be the additional information should be added to triangle IGA and triangle ARI so that these two triangles are congruent under SAA? What is your answer? Very good. The answer is angle GAI is congruent to angle RIA or angle GIA is congruent to angle RAI. Now, let's proceed with our lesson today. Let's start with proving theorems on isosceles triangle. Do you still remember what an isosceles triangle is? I hope so. An isosceles triangle, its legs are the congruent sides. The third side is the base. The angle opposite the congruent sides are the base angles. And the angle included by the legs is the vertex angle. We have different theorems on isosceles triangle. Let's have the first one. We have isosceles triangle theorem or ITT. Isosceles triangle theorem states that if two sides of a triangle are congruent, then the angle opposite them are also congruent. In our example, triangle BAC, if side BA is congruent to side CA, then we can say that angle ACB is congruent to angle ABC. Let's have some examples. Find the value of x for the given figure. In number 1 example, one leg of a triangle measures 2x minus 3 and the second leg of a triangle measures 11. Since the sides are equal, equate them. So we have 2x minus 3 is equal to 11. By applying addition property of equality, we add 3 on both sides of the equation so that we can eliminate negative 3 on the side of 2x. So we have 2x is equal to 14. So to find the value of x, we will divide both sides by positive 2. So 2x divided by 2 is x, and 14 divided by 2 is 7. So our x is equal to 7. To check, since x is equal to 7, substitute 7 in the equation. 2x minus 3 is equal to 11. So it becomes 2 times 7 minus 3 is equal to 11. 2 times 7 is 14, minus 3 is equal to 11. 14 minus 3 is 11. Therefore, 11 is equal to 11. So our answer is correct. Number 2 example. In our given isosceles triangle, vertex angle measures 4 times the quantity of x plus 5 degrees, while one of the measures of the base angles is 2x plus 8 degrees. Since the sides are equal, the angle opposite them are congruent by isosceles triangle theorem, and we know that the sum of the measures of interior angles of a triangle is equal to 180. So we come up with an equation 2x plus 8 plus 2x plus 8. These are the measures of the two base angles, plus 4 times the quantity of x plus 5. This is the measure of our vertex angle, which is equal to 180, which is the sum of the interior of a triangle. So we apply distributive property on the part of 4 times the quantity of x plus 5. We have 2x plus 8 plus 2x plus 8 plus 4x plus 20 is equal to 180. Combining similar terms, we have 2x plus 2x plus 4x plus 8 plus 8 plus 20 is equal to 180. Add them, the sum is 8x plus 36 is equal to 180. Since we are looking for the value of x, we will apply subtraction property of equality on both sides of the equation. We subtract 36 on both sides of equation to eliminate 36 on the side of 8x. So 36 minus 36 is 0. So in this part of the equation, 8x is the remaining value. While on this side of the equation, 180 minus 36 is 144. So we come up with 8x is equal to 144. Since we are looking for x, so divide both sides by 8. So 8, the x divided by 8 is x. 144 divided by 8 is 18. So the value of x is 18. To check, since x is 18, substitute 18 in each angle measurement. Let's start with vertex angle. Vertex angle measures 4 times the quantity of x plus 5 degrees. Replace x as 18. So it becomes 4 times the quantity of 18 plus 5. Applying distributive property, 4 times 18 is 72. 4 times 5 is 20. So adding them, we have 92 degrees. So our vertex angle measures 92 degrees. Let's proceed with the base angle. Base angle measures 2x plus 8. Substituting 18 to x, we have 2 times 18 plus 8. And 2 times 18 is 36, adding 8. So their sum is 44 degrees. So one of the base angle measures 44 degrees. Adding the interior angle of the given isosceles triangle, 92 degrees for the vertex angle, 44 degrees and 44 degrees are for the measurements of the base angle. So it should be equal to 180. So 92 plus 44 plus 44 is 180 degrees. So we can say that our answer is correct. Let's proceed to another theorem on isosceles triangle, which is the converse of isosceles triangle theorem, or CITT. Converse of an isosceles triangle theorem states that if two angles of a triangle are congruent, then the side opposite them are also congruent. In our given triangle BAC, if angle ACB is congruent to angle ABC, then side BA is congruent to side CA. Another theorem that supports the converse of isosceles triangle theorem is this theorem about angle bisector. The angle bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. If we are restating this theorem, the angle bisector of the vertex angle of an isosceles triangle is also the median and the altitude of a triangle from the vertex. Let's have an example. We will prove that side yn is congruent to side YA using the two-column proof. For our statement number 1, as we can see in our figure, we constructed an angle bisector. So YD bisects angle NYA. So this will be our first statement. Let YD be a bisector of angle NYA. So our reason here will be every angle has a bisector. From the statement number 1, we will look for congruent parts. Since YD is an angle bisector, it equally divided angle NYA into two congruent parts. So these are angle NYD and angle AYD. So our second statement will be angle NYD is congruent to angle AYD. So since we are talking about bisector or angle bisector, our reason here is definition of angle bisector. We will mark our figure using the statement number 2. Okay? For the statement number 3, we are going to use the given information. So for the third statement, angle N is congruent to angle A. So since this is coming from our given information, our reason will be given. For the fourth statement, look at the figure. Which part of the figure can be congruent? So for our fourth statement, we can say that side YD is congruent to side YD. What congruence property support this statement? This will be reflexive property of congruence. So let's mark this congruent part. So as we can see on the markings of our triangle, we can say that triangle NYD is congruent to triangle AYD. What congruence postulate support this statement? This will be the AAS theorem. So since we are looking or we are proving side YN is congruent to side YA, and we prove that these two triangles are congruent, for the last statement, side YN is congruent to side YA. So what will be our reason here? So our reason will be CPCTC. Congruent parts of congruent triangle are congruent. Let's differentiate the median and altitude of a triangle. A median of a triangle is a segment from a vertex of a triangle to the midpoint of the side opposite the vertex. Here are some of the illustrations. LN is the median of triangle LAB. OA is the median of triangle LOD. How many medians can a triangle have? Yes, there are exactly 3 medians, one at each vertex. While an altitude of a triangle is a segment whose one endpoint is at a vertex of an angle and the other endpoint is on the opposite side, or an extension of opposite side of an angle, and it should be perpendicular to the opposite side. So we have here, DR is an altitude of triangle DAK. So, angle DRA and angle DRK are right angles. Second, GR is an altitude of triangle GAY. So, angle GRA is a right angle. How many altitude can a triangle have? Correct. There are three altitudes, one at each vertex. Let's proceed now on proving theorems on right triangle. Do you still remember what a right triangle is? Yes, of course. Right triangle is a triangle in which one angle is right. When we say right angle, the measure is 90 degrees. I have here a figure of a right triangle. Side BA and side BC are the legs of the given triangle. Angle ABC is the right angle which is measures 90 degrees, while side AC is the hypotenuse. Let's go now on theorems on right triangle. The first one, we have LL congruence theorem or leg-leg theorem. This theorem states that if the legs of one right triangle are congruent to the legs of another right triangle, then the triangles are congruent. In our given example, we have triangle ABC and triangle FED. If side AB is congruent to side EF and side CB is congruent to side DE, then triangle CBA is congruent to triangle EDF. Let's prove triangles under LL congruence theorem. In this problem, we will prove that triangle YNA is congruent to triangle JOB, given that angle N and angle O are right angles. Side YN is congruent to side JO, and side NA is congruent to side OB. Usually, the first statement is coming from our given. So our first statement will be angle N and angle O are right angles. So this is coming from our given information, so our reason will be given. To come up with our statement number 2, we are looking for a congruent part coming from the statement number 1. Since angle N and angle O are right angles, so they are congruent or they have the same measure, which is 90 degrees. So we can say for the statement number 2 that angle N is congruent to angle O. What will be our reason here? All right angles are congruent. So since we come up with congruent part, for our third statement, we will go back to our given information. So we have side YN is congruent to side JO and side NA is congruent to side OB. Again, this is coming from our given information. Our reason will be given. So we will mark first our figure using the statement number 2 and 3. So we have angle N is congruent to angle O. They have the same marks. YN or side YN is congruent to side JO, having two ticks, which means they are congruent. Side NA and side OB having the same ticks, so they are also congruent. So coming from the given figure, we come up with a congruence postulate. So we can say that triangle YNA is congruent to triangle JOB. So what congruence postulate supports the given information or statement number 4? So we can say that this is supported by SAS postulate or side angle side congruence postulate. Let's have another theorems on right triangle, which is LA congruence theorem or leg acute angle theorem. LA congruence theorem states that if a leg and an acute angle of one right triangle are congruent to a leg and an acute angle of another right triangle, then the triangles are congruent. We have here triangle ABC and triangle DEF. If side CB is congruent to side FE and angle BCA is congruent to angle CFD, then triangle ABC is congruent to triangle DEF. Let's prove triangles under NA congruence theorem. We will prove here that triangle YNA is congruent to triangle JBO, where angle A and angle O are right angles. Side YA is congruent to side JO. Angle N is congruent to angle B. Our first statement is usually coming from our given statement or given information. So number one statement will be angle A and angle O are right angles. So what will be our reason? This is given. For the statement number two, we should come up with a congruent parts coming from the statement number one. Since angle A and angle O are right angles, therefore they have the same measure. For the statement number two, angle A is congruent to angle O. So what will be our reason? All right angles are congruent. Let's mark this statement in our triangles. Angle A is congruent to angle O. Since we come up now with the congruent parts, let's go back to our given information. This becomes our statement number 3. Side YA is congruent to side JO. Angle N is congruent to angle B. The reason will be given. So mark your triangles. Side YA is congruent to side JO. Angle N is congruent to angle B. So using the figure with marks, we will come up with congruence postulate or theorem that supports that these two triangles are congruent. So we can say now that triangle YNA is congruent to triangle JBO. So what will be our reason? It is AAS congruence theorem. Another theorem on right triangle is HYA congruence theorem or hypotenuse acute angle theorem. HYA congruence theorem states that if the hypotenuse and an acute angle of one right triangle are congruent to the corresponding hypotenuse and an acute angle of another right triangle, then the triangles are congruent. In our given triangle ABC and triangle FED, if side CA is congruent to side DF, angle BAC is congruent to angle EFD, then triangle CBA is congruent to triangle DEF. Let's prove triangle under HYA congruence theorem. We will prove here that triangle YNA is congruent to triangle JBO. Given the information that angle A is and angle O are right angles. Angle N is congruent to angle B, side YN is congruent to side JB. Our first statement is coming from our given information. So statement number 1 will be angle A and angle O are right angles. Angle N is congruent to angle B. Side YN is congruent to side JB. The reason? It is given. So we have here two congruent parts. So let's mark them with our figure. Angle N is congruent to angle B. Side YN is congruent to side JB. So since we have here in statement number 1, angle A and angle O are right angles, we should come up with a congruent parts. So for our statement number 2, angle A is congruent to angle O since they are both right angles. So what will be our reason? All right angles are congruent. So we will mark angle A and angle O are congruent. So looking to our figure or our triangles, these two triangles can be supported by a congruence postulate or theorem. So for the third statement, it will be triangle YNA is congruent to triangle JBO under the postulate or theorem AAS theorem. Last theorem on right triangle is HYL congruence theorem or hypotenuse leg theorem. HYL congruence theorem states that If the hypotenuse and a leg of one right triangle are congruent to the corresponding hypotenuse and the leg of another triangle, then the triangles are congruent. In our given two triangles here, if side BA is congruent to side ED and side AC is congruent to side DF, then triangle ACB is congruent to triangle DFE. This time, we will prove triangles under HYA congruence theorem. We will prove that triangle HPO is congruent to triangle HPE, given that angle HPO and angle HPE are right angles. Side HO and side HE are also congruent. For the statement number 1, we will get it in our given information. So this will be angle HPO and angle HPE are right angles. So the reason will be given. Coming from the statement number 1, we will come up with congruent parts. Since angle HPO and angle HPE are right angle, therefore they have the same measure. So we can say as statement number 2, angle HPO is congruent to angle HPE. So the reason will be all right angles are congruent. We will mark it in our figure. So HPO, this one, angle HPE, we will mark it. So for the third statement, let's go back to the given information. So as third statement, side HO is congruent to side HE. So what will be our reason? So this will be given. Since we don't have other given information, we will look at our figure. What other congruent parts may we get from the two triangles? So, for the fourth statement, angle O is congruent to angle E. What theorem or definitions can support this statement? So, this will be isosceles triangle theorem. According to isosceles triangle theorem, if two sides of an isosceles triangle are congruent, then the angle opposite them are also congruent. So we will mark it as angle O is congruent to angle E. Opposite of side HO is angle E. Opposite of side HE is angle O. So now, we may now conclude that these two triangles are congruent as our statement number 5. Triangle HPO is congruent to triangle HPE supported by AAS theorem. Thank you for listening. If you have questions, feel free to send a message to our official page, Math Team Mathematics Teacher of Mandaluyong, or send a message to your math teacher. This is Mrs. Clara saying, Math-sayang Math-aral, tayo ng Math-tuto.